The broadcast is now starting. All attendees are in listen-only mode.
All right, thank you, Mike. Welcome to the Texas Section ASCE webinar. Thank you all for joining us for today's section webinar titled Blurred Lines, Undefined Roles of the Engineer, Subsurface Utility Engineer, and Surveyor, presented by the Texas Utility Engineering and Surveying Institute. This webinar is the fifth in our series of monthly webinars for 2018. I would like to thank the branches for hosting viewing sites all across Texas. As the State Association for Civil Engineers, we are happy to provide this service to the engineering community. If you are not a member of ASCE or the Texas section, I invite you to become a member so that you can benefit from being part of our professional association. Now I'm pleased to introduce our presenters for today's webinar, Renee Mayer and Jesse Cooper. Renee is a professional engineer, graduated from the Texas A&M University, and had a career of 20 plus years centered around all aspects of utility in design, coordination, engineering, utility adjustment, verification, beginning her work with CPS Energy, a major gas and electric company for San Antonio, where her passion grew in the utility industry. She saw quickly how utilities play an intricate part of project delivery. Her background has given her an appreciation of the dynamic interaction required between the utility owners, design personnel, and construction contractors necessary to successfully execute complex, fast-paced projects. Through her depth of experience, she has created an impeccable process of identifying, resolving utility conflicts through solutions that benefit both the agency and the utility company while maintaining project schedules. As the Transportation Utility Program Manager for HDR Engineering, she has a proven record managing successful on-time, on-budget delivery of projects of all sizes in Texas urban and rural environments with a multitude of agencies, including several TxDOT districts, many cities, including San Antonio, San Marcos, Kyle, Cedar Park, Austin, Pflugerville, Round Rock, and counties, Baxter, Hayes, and Travis, along with the Union Pacific Railroad. She was utility manager for the team that was the recipient of the FHWA 2011 Excellence in Utility Accommodation and Relocation Award for incentives, and part of the team presented with the APWA Texas Chapter Project of the Year for 2017. She is the president of the Texas Utility Engineering and Surveying Institute, and as indicated, Transportation Utility Program Manager for HDR. Our other presenter is Jesse Cooper. He's the Senior Utility Manager for HDR. Jesse has a Bachelor of Science from Texas A&M University and is a professional surveyor in Texas. His career has centered on all aspects of utility coordination, utility engineering, utility relocation, SUE, utility adjustment, monitoring, and verification. Jesse currently provides leadership for the HDR team on projects such as the Rapid Bridge Replacement Project in Pennsylvania for the utility relocation analysis of over 500 bridges and the updating of the North Carolina Utility Manual. As the former TxDOT Section Director of the MAP Survey and Utility Section, Jesse provided oversight of the Texas Utility Program relocating utilities for transportation projects. He also managed subsurface utility contracts and developed a contract template which is now used for professional utility coordination contracts. He was part of the team presented the FHWA 2006 Utility Outstanding Achievement Award in the category of Utility Subsurface Utility Engineering. With those introductions, I'm now going to turn the presentation over to Renee and Jesse. Thank you.
This is Jesse Cooper. I'll be starting the presentation, and then we'll be turning it over to Renee as we get to that section.
Yes, hello everybody. All right.
Okay, our title is Blurred Lines, Intersection of Surveying, SU, and Engineering. And you may wonder about, it seems like the roles are pretty set. I'm an engineer, I'm a surveyor, I'm a supervisor. But our goal today is to look at the overlaps. And really, our goal today is to assist you in not letting utilities ruin a great project. That is what we all want to do at the end of the day, is not have something like is occurred up in the upper left-hand corner. This was a project in East Texas, and fortunately the operator was not hurt. He heard a hiss of gas and jumped and ran. Blurred lines. I'm not going to read the entire slide here, but the roles of the surveyor and the supervisor are both mostly in today's practice is collecting data. And collecting the data of where utilities are located, the X, Y, and Z. Surveyors normally working above ground and supervisors normally underground, but both use indicators of utilities that are above ground as evidence of those below, and vice versa. What I would like to state right here is that surveyors are experts in measurement. That's the reason they gain their seal as a registered professional surveyor, knowing which equipment to use, the procedures and practices that will give the standard of care that you look for in a project. Supervisors do that, working on the subsurface environment, and currently work under the direction of engineers. What we're going to do is look at the relationships, the responsibility of the three parties, the utility engineer, the SU engineer, and the surveyor. First, we're going to start out and just, throw it out there for everybody to think about. What is the difference in a utility survey, subsurface utility engineering product that you might receive, and what is utility engineering? Is that just collecting data, or is that something different? To help with that, we have a pre-session survey. Who should perform the following task? And I challenge those out in the audience here as we talk about it to decide, do you believe the project surveyor should perform this task, the supervisor, or the utility project engineer? Or do you see these activities performed by more than one, or maybe even all three? And my question to us as we go through the questions, that we say, is this a duplication of work that may cost additional funds? Is it worth the additional funds? Or is it a duplication that performs a QC role? Or maybe there are gaps that we are not addressing at this time. The first is calling 811, and we're, as you know, would be talking about normally here a design type of call where they would mark on the ground, or if a supervisor is working where they have to do a level A pothole. How many of these three individuals obtain utility records? How many provide storm sewer flow lines? How many spot the accuracy of locating utility poles? Are you locating a pole to the center of the pole, to the edge? Do you know the quality of data that you're collecting, and is it important or not? When should level A or B SUE be required? Who makes that determination? Who identifies the conflicts with all of the data that is collected? And who is responsible for resolving these utility conflicts that are identified? Those are the things we'll be talking about. First, we're going to start with the surveyor. Normally, that's first in the process. The first one's on the ground looking at projects. And the benefit of using a professional surveyor is he uses professional judgment, methods, and equipment in collecting data. As I stated before, he's an expert in measuring distances, small distances, great distances, whether to use the old transit or GPS or LiDAR or whatever the method is. He also is proficient in collecting complete data and sufficient for the project that is being to be performed or designed. Needless to say, with this, it should be accurate, and you will have the liability for those measurements transferred on as he will be signing and sealing his deliverables. Now, when we go out on a new project and our surveyor goes out, the normal surveyor today in practice identifies companies by signage, you know, the little placard that'll be on a power pole or on the telephone box. He may call and request utility records from the utility companies. He may call the 811. He will then depict what he finds on the roadway plans and files. He performs QC and reviews, and if needed, he'll go back out onto the ground and try to do some further research to locate where a utility goes or who the owner is. Now, we have questions. A surveyor comes in, as we talked about before, with poles. Surveyors normally pick up the sewer manhole that you see on the right, the top. But then my question becomes, in your firm or in your projects, who picks up the inverts? Are you relying on a supervisor to do everything in the subsurface? Or are you looking to the surveyor to be responsible for that? Many times this requires lane closures, as in this one right here, protection, and then identifying the lines that are below the surface. What we recently had was a discrepancy in contracting where the surveyor said, well, all of the subsurface is by the supervisor. Supervisor says, well, we assume the surveyor was picking it up. The photograph on the left, you see the poles that are there in determining who owns the pole, who maintains those, and the electric lines between the poles there. Also the distance to the back of curb. You know, if you're working on a widening project and all utilities are supposed to be 3 feet behind curb or 2 feet, where you take those measurements, you may be showing a pole to be in conflict when it may not be, or the other way around. We see the same type of thing in our next slide here for surveyors. As surveyors would go out and normally pick up the corners of the slab, they would try to pick up the major infrastructure on top of the slab and identify it by the placards that you see on the boxes as to ownership and maintenance and contact information. As you can see right here with the pedestals right behind the curb, or I say the posts that are protecting those facilities, that the distance off of the back of the curb is critical for safety. Now, this is not a picture necessarily of a transportation project, but it is a picture that very much identifies the items that I believe a surveyor needs to pick up on the ground and be considered. With an HFrame post, as we know, most surveyors would pick up the post, would draw a description of the approximate size of the post and how long the arms are out from each pole. But if you're doing a utility survey, you will be looking at the sag that are in these lines and identifying, what type of facility, the ownership of that line, and if we're running a road or any equipment underneath, we would be able to identify conflicts with OSHA zones to electric lines. Now, the other point right here is a surveyor would need to note the date and the temperature when he's taking these, the readings or the shots on those lines, because they have a different sag. Our lines have a different sag according to the temperature. Again, we're pointing out the responsibility of a surveyor or practitioner knowing the exposure he has as they are collecting data and collecting the appropriate data. Okay. On the left is a normal communication pedestal, and I laughingly say right here, well, our surveyor always picks these up as he's going along beside the road. And then our supervisor is also picking them up as he is identifying the underground copper or fiber wires that will be going to the boxes. So we see a duplication, but it is a needed item to be picked up. And I believe our main concern is when the supervisor has it in one location and the surveyor shows it about 3 to 4 feet from there, which we do see occasionally in the normal day-to-day activities. But you notice that we take the picture of the warning signs and we can identify the above ground features in the surveying activities. Now on the left, or on the right, I'm sorry, we show 4 lines there. And the thing that comes up that a lot of surveyors do not do, and I believe we need to talk about in the future as who it is appropriate to perform this job function, is find out the owners of those lines. Normally, as you know, communication lines, bigger, heavier lines have a different clearance and they are lower than electric lines. So you may have a Encore pole and then have a Spectrum line on the pole, maybe a Verizon. You may have as many as 3 to 4 different utility companies located on one pole. So identifying those owners, listing those, this is one of the activities that I see sometimes surveyors do, identify, then the supervisor is checking, and our coordinators work and find out, and our utility engineers. I believe that we all should be cognizant and looking for tenants on one facility that may be owned by another. And we'll talk about this a little bit more as we go on. Subsurface utility engineering, as we move from the surveying side to the SUE side, the definition of SUE, and I'm sure most of y'all are familiar with SUE products, that is the ability to collect, interpret, and graphically depict underground utility information to a defined standard of accuracy. Now, when we do an 811 call, and I just picked this slide right here because I really liked it. Quality level D is normally what you find in records. You call, you get your one call, and they give you a list of utilities that are in the area. Now, when they go out and start marking, and maybe your supervisors follow along, you may end up with a lot of pin flags like we show right there. Those are our favorites. With each color flag representing a different utility and how close they are in proximity. But the thing to note right here is that level D is composite old drawings, record data, and until all of the flags are surveyed in, it's just record data. Quality C is identified when you have the surveyor and supervisor working together there, and they pick up those pin flags, the above ground appurtenances that we just talked about a few moments ago, and the survey data and the record data are correlated to each other, or maybe overlaid on each other. This normally has to be done using professional judgment and experience in the part of saying, here's where the record drawing shows this item, and here is where we see something on the ground. Or is there extra data that we find in the survey and we know that we don't have all of the data? Or maybe we have record data and there's nothing been found in the field. These are known as quality level D, and then using quality level C to correlate the two records and what's on the ground. This is an example of quality level C, where they're working together and drawing using record drawings and showing what is on the ground. Now, with this, we'll move on to quality level B. This is one big differentiator between surveyors and the supervisor in the current day practice. Now, I will say, I did mention that surveyors are experts in measurement. Many surveyors actually work for the Sioux firms and perform these tasks. And that's one of the things across the nation is being looked at today. Can surveyors actually perform and sign and seal Sioux documents? It's an active conversation at the federal and the state level. But for the moment, subsurface geophysical techniques include pipe and cable EM locators, resistivity, metal detectors, ground penetrating radar, X-ray methods, sonar, optical. There are many methods of investigating the subsurface environment. Here's some pictures of some of that equipment where they are working within, working with the lines, put an instrument on the line, and then see the conductivity and monitor where the line goes. Here's some ground penetrating radar, sonar, where you can see in this picture right here, you get the waves, how they come back. And when you run the programs associated with this, specialized programs, it will show you the strongest signals and help you identify the lines that are underneath the ground. These are normally, in today's environment, are normally up to about 10 feet, but new equipment, new methods are looking for deeper, and we are constantly seeing technology changing, And one of the things I would suggest everybody be aware of is to know the limitations of the equipment that your consultants are using, to know if their equipment is adequate to be providing the data that is required by the soil types and depths. Okay, one of the next things, we have a picture right here that is going into quality level A of SUE, and quality level A is exposing with non-destructive methods, getting down to a pipe and being able to physically shoot the elevation with surveying mechanisms where the utility line is visible. That can, these are needed many times when the accuracy, when you know that you're within inches or very extremely close to a gas line or a line that would severely impact the customers, and we want to avoid the risk of harming an existing line. Now, the real questions come up is the selection of where do we need the quality level A, these test holes. Who should be making that determination? This is a picture with quality level B data overlaid onto an aerial right here, and they're picking out locations with the dark orange bigger lines where they will want some test holes. Many supervisors and many of the layman coordinators or surveyors may intuitively know because of the project that probably test holes will be needed, but the real question is, not question, but the person that will know if a test hole is required is actually the designer of the transportation project. Working with the utility engineer, or the utility engineer working with the project engineer to determine, okay, our sub-base is at 3.5, 4 feet below existing grade, and we know there's a gas line at about 5. We probably need a test hole and know exactly how deep it is. When the approximate locations will not work, and the designer knows the location of his proposed facility, the utility engineer, the supervisor has gained the exact location of the utility line, and everybody has to work together to make sure that we do not have an explosion like we did before, or the picture we had at the beginning. So the real question is, we are now moving into that that process to determine by value engineering, by engineering process, when do we go to the next level of quality level A. So at this point, we're going to turn the session over to Renee Mayer, who, as we know, is a professional engineer and been in the business for a long time. And I have to say, she has developed methods and processes that do protect utilities and our transportation facilities. So with this, we're going to turn it over to Renee.
Hi, everybody. I hope you're getting some lunch in this afternoon while you're getting to take a little PDH credit. So hopefully we'll give you a little bit of valuable knowledge here. When do we use a professional engineer? I mean, what is a utility engineer? It's kind of a new terminology, right? I mean, you go to career fairs and you got people come up and it's like drainage engineer, highway engineer, structural engineer, water resources, but they don't say, well, what's a utility engineer? Well, we need to change the game because, as we know, utilities stop projects, and we've known that for a long time. It was the two main things, right-of-way and utilities. So the problem is the utilities have increased, the highways are increasing, and it's too costly to buy enough right-of-way to fit everybody in. So we got to all fit together. And who takes on that responsibility? You know, we need someone. Is it the design engineer? Is it the consultant? Is it the surveyor? I mean, we never know. And the design engineers are trying to design their specific disciplines, their drainage, their roadways, their retaining walls, their bridge columns, or the bridges. And so they don't have time to deal with all those utilities and everything there. So who takes on that responsibility? The goal nowadays is what we need to get to. And we pulled up another the other day, Jesse, what was it? Still 80% of projects are going to construction and still have conflict, with utilities. They haven't been resolved. And it's how many millions of dollars still being spent?
Back in 2016, in Texas, it was in the neighborhood of $40 million a year that was being held up and attributed to utility delays. Now, of course, that's subject to different ones in that determination, but what we see is a tremendous amount of money and delays because of utilities.
Right, and so we need someone to take the responsibility of that, somebody specialized in that to handle that. What do we need to analyze the utility data? Like Jesse was saying, who determines how much do you get? Because it's expensive, getting a bunch of test holes is very expensive. So we need to determine exactly where they need to be. We need to know when you need quality level B. You don't need that every single time if you already know the existing lines under proposed pavement. And then we need to know who's going to be that person that is responsible for identifying every single utility conflict. It's easy to take all the design plans, send them to the utility company and say, hey, utility company, do you have any conflicts? Well, does that ever come back? I mean, how many times do those utility companies take ownership of that and go through the information? And do they really even know how to truly read a full set of PS&E plans? There's a lot of disciplines all involved in there. So a utility engineer is a person that can read drainage, can read roadway, can read the structural, the retaining walls, and work with all these disciplined engineers to come up with the best solutions for each and to resolve each one of your conflicts. Then in the end, we can provide a signed and sealed deliverable, and that transfers that liability to a professional engineer. And utility companies understand it, and they're on board more because they don't have to deal with it. Our client knows there's somebody taking care of this information, and our designers that are designing roadway and drainage can focus on what they're specialized in. When we're identifying conflicts, we don't just think about our design features, what I just talked about, all the proposed roadway features, all your drainage structures, your retaining walls, your bridges. But we also got to think about construction activity. Look at this giant 39-inch pipeline they were putting in. I mean, there was a lot to think about when we had to install this. We had to think about everything around it, not only, but how many trees are going to be in the way? Are there any high lines in the way? Then also you got to think about your existing and proposed other utility facilities. And last but not least, look at non-compliance. Just because they're not impacting physically with the proposed feature, you got to make sure you're hitting all your UAR minimum regulations and minimum clearances and depth of cover. And last but not least, don't forget about safety and accessibility regulations. How do you do that? Everybody probably has a different plan. I've kind of been putting together these very visual utility layouts for years, and people love them, especially utility companies and contractors. We have them hanging in construction trailers because they're so visual. It's very easy to go through and see that all the white lines are, all the proposed features. You have your aerial background. The display of colors are very vivid. And then we go through and comb through every single thing and make sure we've identified every single conflict. Now, this is all going to 3D nowadays, right? Everything's going to 3D, which is great because it's even a better visual picture. But the concept's the same. You still have to document your decision and why it's clear or it's a conflict. So we go through and we list all these, and then we pull elevations from all the design plans. It's not just eyeballing it. We specifically go through and pull in conflicts and go through a calculated effort. And if we're lacking information, that's when we go out and determine where we need additional SUE. Then we can surely determine if it is or isn't in conflict and what it's in conflict with, and that's when we start working with designers on what we do next. Sometimes what we do is we provide a lot of support backup, including cross-sections, exhibits. I mean, you see in this little area here, these are all areas that were going to be excavated. And you can't forget about the little water line that's sitting in that excavation area, or your fire hydrant that's so close, and we may need to make adjustments here. But these are all support evidence backup that we provide for each conflict ID. And why do we have all that information? Because we can start looking at how are we going to resolve each conflict. We don't want to jump right into relocation. We want to look at avoidance. So we go into, and I'll go into some examples on working with the alignments, the roadway alignments, the drainage, and the structures. There's a lot of times we have a particular project now that, you depending on who's designing it, maybe they didn't have the utility information, but they laid out a proposed storm sewer line right on top of a whole bunch of existing utilities, where they could have just designed it to the outer separation, or even pushed it under the frontage road and did a different type C, inlet to avoid millions of dollars of utility relocations. So that's where a utility engineer who specializes that can work with those designers and say, hey, let's avoid having to relocate and save a bunch of time and money for the project and make sure we get clear. Other things are minimizing it by protecting in place. We can do different kinds of retaining walls or caps or encasements. And last but not least, there are times we have to relocate, and there's times when exceptions may be necessary when it's a situation that it takes a lot of time and money, and there's avoidance that has to be occurred, and exception is just the best option at the time. But we have to look at all exceptions. Here's a couple of examples where instead of relocating this large pipeline, we put a split casing around it that provided it allowed it to be a little bit shallower than the full depth of cover, since you had that protective casing. Same thing here. This was a large drainage ditch going in, and so we poured a large concrete cap to protect that pipe. Here's another little example. We were like, what is this? What's going on here? And a drainage channel was going to come in right here. And so we didn't know what that was. We'll come and find out. It's a big underground electric switch. It was a switchgear box that was an underground electric duct bank. That was going to be millions to relocate all that. And because this was going to be our proposed drainage channel. And so we worked with the drainage engineers, and we developed a vertical wall to put here to avoid all this. And this was all just concrete riprap in here. And yes, that was a lot more expensive than an open channel, but not near the cost as moving an underground duct bank and replacing them. A lot of times we've designed these multi-duct banks with other utilities, and we've learned that the cost to relocate underground electric many times can get to like 800 to 1,000 a linear foot. So you don't want to relocate that if possible. Here was the finished product after we made those design changes. Other things that you may forget about is environmentally sensitive areas. So we need to think, do we want to go through a whole environmental process if we have to relocate a pipeline and a long bore under here? So this is when you might think of, which is not preferred with DOTs to hang pipelines from bridges, but in this case, it was a hardship situation, and it made the most sense, and it's just an option to look at. What do we always forget about? We get everything moved. We've identified conflicts with proposed features, but then we forget about the constructability issues. Here, Jesse was talking about when they introduced him, we talked about the PennDOT program. Well, this is one of the bridges out of the PennDOT, and there was 568 bridges on this particular project, and we had to think about more than just conflicts with features. The biggest thing is when you're building bridges, you have cranes all the time, right? And so you're going to have a crane coming in on each side of the bridge, depending on the length of the bridge, but how close they have to get it to replace, whether it's culverts or the bridge beams are coming in. They have a lot of cranes going on. And you forget about these areas like right in here where you have an overhead telephone or overhead electric that's cleared from the proposed features, but it would have been in the way of the cranes. Also, we forget about OSHA clear zones. Here's an electric line going here. And although it might have been cleared of the proposed feature, you got to think about that 10-foot to 25 feet, if it's a transmission line, OSHA clear zone. And so you don't want to get out in construction and have forgotten to work with the utility companies and come up with a solution for that. Thirdly, excavation zones. Right down here, look at this sanitary sewer line right here crossing this excavation zone. Nobody, it's way far from the proposed feature and everything going on. Nobody would have thought that'd be in conflict. But if you determine an estimated excavation zone, it definitely could be. So if we, and right here, we still show a potential because what we did is, of course, worked with the designers and made sure the excavation stopped short up there to clear conflicts like that. But these are three areas that doing shading, it just helps the utility company understand when there was a conflict going into construction because they can't visualize it. And this helps everybody visualize and not miss potential conflicts that can occur so that we can avoid them or mitigate them and just make sure they're resolved prior to we let the contract and having delays in the field. Here's another area we forget about is temporary easements for construction. Many times we got to build a little detour road while you're building the bridge. Well, you come around here and you're excavating. Anytime you hit a shovel in the ground, there could be a utility there. Or while you're building that road, what all's going on in there? So all this has to be looked at. And we all forget about because many times the traffic control plans don't come in until 60% design or later. It's all coming together and we've already put in our potential conflicts. Well, we got to go back and check those out too. So just make sure and remember construction, all your temporaries, your construction phasing, don't forget about those things that you may, that could cause delays. All right, so we've gone through, Jesse went through the survey, we've gone through the SUE, we've pulled in all the information, we've analyzed all the conflicts, we've got someone that is responsible for that, that's signing and filling documents, so we have this perfect product, right, that we've reviewed all the utility plans to make sure their relocations are going to be clear. Well, then what happens? Like, does everybody go away and go home and everything's fine? Well, what happens when that utility company goes out there and installs and he finds something in the way? And that's where Jesse's going to pick up and talk about other problems that might could happen, so, in construction.
Well, you know, everybody raises their hand and says, we got a utility agreement, we've got plans, utilities are taken care of. And in the normal project, most utilities are moving before the construction, or, you know, within a couple of months of construction as it goes. And so, you know, we have to watch those because the contractor is not done the notice of intent to begin construction to the FHWA. And, you know, the other question is they're out there and they're working. Who is looking after those utilities that are moving prior to the contract when we don't have normal inspectors and nobody's in the area? The things that we need to be looking for or should be watched and monitored during construction is, are they following the SW3P plan, stormwater pollution prevention plans? Do they have them on site? Are they complying? Traffic control, they're working next to lanes. Are they closing down a lane? Have they given notice to the DOT or any other authority to have a lane closure? Are they adhering to the OSHA and safety regulations? Are they putting the utility where it belongs? You know, if they don't locate it correctly, it will delay your project. or it will cost extra money to relocate a second time. Have they put in their utility markers? Have they given you revised plans or as-built as needed? In utility construction management, there's some best practices if you are working on a job, and that is to obtain their utility schedule, their agreements, their plans, their permits, have all of those documents available. Include the utilities in pre-construction and construction meetings so that they know the impacts of the construction on their work. And the middle one right there in red, are you having constructability coordination meetings with them so that you can identify those OSHA and other regulations? It may not be an OSHA, it may be a cable TV, just an overhead crane zone. But have you identified all of those exposures? So let's go back to the very beginning as we start closing out. Who should perform the task? Who should call 811? Who should obtain utility records? Who's responsible for providing storm sewer flow lines? Who determines how accurate the utility poles are located? Who determines level A or B SU? Identifies the conflicts? And who is ultimately responsible for resolving all of these utility conflicts? So many times we all try to dodge that bullet. That's the reason that I believe utility engineering is at the forefront of our industry right now. So with that, I believe our time is just about up, and we can open up for questions.
All right.
And we thank y'all for this time that we've been able to talk and present. We welcome your feedback and questions. Okay.
All right, thank you very much. Let's see. Looking for some questions here. When having to go between a level B and level A documentation, when you're deciding who decides who it is, also how do you communicate to the client what's necessary?
So they want to determine on whether they use how much quality level B and how much quality level A?
I guess so.
So what we do is we put together a SU work plan. And when I showed that utility conflict matrix, when you're going through and entering in actual elevations and you get to the elevation of the utility, and you know, so if it's a crossing, that's how you know you're going to need the true depth. Or if you're right next to a drill shaft, then you're going to need to know the true XY, and you may need to do even more than quality level B. But it all determines when you know what level to go to is where you are in your conflict analysis, because the more precise horizontal and or vertical information you need, that's when you know when to get quality level B or quality level A, or even how much you can just use the D and the C. What I don't ever recommend, and I always persuade TxDOT is, or any of our clients, is don't go out and just do a full broad quality level B all the way through and get, 50 test holes, because at 30% design without drainage, you're going to need more precise information, and or you're not going to need so much precise information in areas where there's not anything going on. So you don't have to spend millions of dollars or hundreds of thousands of dollars in doing STU if you pick where you need it and how precise you need it.
If a utility is underneath the pavement and it's very apparent that it's going to have to be relocated, it's only a couple of feet deep now, there's no use in doing SUE on it. You just go ahead and go straight to working with the utility to relocate the line.
Right. You don't want to waste that kind of money. But that's, to me, that person being responsible of combing through the conflicts and getting good information to determine how much SUE needs to be spent.
Okay. When or what phase of a project is the best time to bring in your subsurface utility engineer?
Well, that's kind of basically what I was stating before. What we do, and seems to work the best, and it is nice sometimes to come on a project and that, you know, SUE has been done, some quality level B, or, you know, even some C and D. But what we do is we come in and say we're in the beginning of a schematic phase, and we do, because HDR does not do quality level B and quality level A. But we do, you know, we pull all the records and we create a utility layout and we start the conflict analysis. And we always work, and this is where the blurred lines come in. If there's a topographic surveyor going out there to get survey for roadway, and that's when we'll say, go ahead and pick up those above ground apparatuses then. And then we can use that with the record drawings and create and get our layout initialized. Then we can create a SUE work plan when we know where the precise information is. So to me, the best time to start your SUE, the quality level B and A, is when you know where your drainage, at least your drainage line, trunk line is set, so that you can have, you know where the best places is to get that quality level B and A.
I think in best practices, one of the real questions is when do you start addressing utilities? And if you noticed in the very beginning, we talked about surveyors collecting data. We made an assumption that they are collecting utility data at that time. What we find in real practice is in the schematic phase, the surveyors are not picking up, but just very, very minimal utility data. And so the real question is when do you start really addressing utilities in your highway or transportation design project? And we say as early as possible, because the transmission line, the major utility, may cost as much to relocate as your transportation project. So you naturally, if you can move to one side and
your alignment,
avoid it,
yeah, you
will want to do that. We also, I believe, need to be concerned with the point of multiple people working with the utilities. Having the surveyor, the supervisor, the utility engineer, project engineer, and utility coordinator all working on the project. One point of contact or one responsible party be reviewing all data that comes in to help with these decisions. And that should be, as Renee has been talking, the utility engineer. At the end of the day, be responsible for that coordination. You don't want to make somebody that's only going to be working in a small portion of the project ultimately responsible for the consequences of that one task or impacts to the project.
Excellent. All right. Mike, do you have any other questions that came in on your side?
Nope, I don't see any others.
All right.
Okay. Well, Mike, one question that we've had a lot across the nation that's being looked at, and I think it deserves a moment of time here, is the fact, should a supervisor or the survey and a surveyor both be able to sign the documents? I did not make the statements here, but I have in longer presentations where I talked about surveyors in the old days did everything with a steel tape, steel chain, and a transit. As the GPS, or as first electronic distance meters came along, surveyors for a period of about 10 years adapted and did work in dual methods until they gained confidence in the electronic distance meters. When GPS came along, they spent a number of years also verifying, working with the new data. Now, as we go into ground penetrating radar, sonar, all the new technologies, what is evolving is a confidence level in the electronic data, and especially depths. New methods are being promoted daily almost on how to get a more accurate reading. So the question becomes, can a surveyor perform these functions? How accurate they are, and where is the future going? Many of the states are really looking at the fact surveyors are experts in measurement, and should they move into this subsurface environment with supervisors, and ultimately working for the engineers. So just some thoughts on that, and I think you'll be seeing more of that played out over the next couple of years as the states determine which way they should go.
Okay. All right. Renee, I believe you had a couple announcements as the UESI president.
Yes, thank you for giving me a second. First, I don't know what kind of audience and where the backgrounds come from, who's listening in today, but the Utility Engineering and Survey Institute was created about 2 years ago now, and about 9 months ago, well, it was about a year, they nominated me in to start the Texas section, and in July of 2017, we finally got our MOU executed, and we became an official chapter, and we had our first meeting at CECon in September, and then our quarterly meetings we started up in October with short course last year, TechStop short course. Then we had one in late January in the Fort Worth area, and then we just had another one this past Friday in Houston, and we had a really good crowd. The Texas chapter's apparently doing amazing things versus and growing super quick. We've got a lot of committees. One is we've got a conference committee, so we're going to be having a conference in the second week of March at UT Arlington. And a lot of this is because everybody right now has problems. Every project has utilities, and we need people to deal with this. And to find people with this kind of profession or specialty, it is hugely difficult because there's not very many of us. So we also have an education committee, and we're pushing that into the universities. And being from A&M, of course, I was an advocate to start there. And we also have a good connection with the Texas Transportation Institute, Cesar Griego. And so we are looking to start a curriculum in utility engineering with the universities. So keep those dates in mind. If you know anybody out there, or if those on the line that are interested in getting more involved in utility engineering, we can send out more information about the specifics. Our next quarterly meeting, we have to hold one at CECon coming up this September, and then we'll have another one early December in like San Antonio or Austin. So keep those dates in mind.
Yes, I'd like to follow up with that. There are several ASCE committees right now that are looking at, number one, the SUE background is the 3802 standard for SUE is being looked at as being upgraded right now. And there's a data exchange between utility companies and municipalities that is being worked on to electronically be able to transfer data. So involvement in the UC will allow you to be able to participate in the next steps to take our profession forward some giant leaps.